Welcome to Systems Are Go. My name is Eric McLaughlin, and I'm the astronomer for the Rancho Mirage Library and Observatory. And this month, we have a lot of interesting things for you to see. As you relax to these views, keep an eye out for a halo around the moon. We'll talk a bit about the opposition of Mars, as well as a really nice sunspot, along with, of course, all our nice weather data. With that said, again, relax, and I'll touch base with you later. October 13th marked the opposition of Mars, meaning that Mars was on the opposite side of the sky from the Sun. That meant it was up in our sky essentially all night, and we were able to get a nice set of images of it. This image shown here is constructed from a stack of the best images out of thousands taken over about 10 minutes. It was taken shortly after 9 p.m., which corresponds to the time of our Distancing with the Stars video. So if you have not seen that video, we have a link for it right here and in the description below. In it, we explore all the features marked here, as well as a number that are on the night side of the planet at the time of this image. Now go ahead and enjoy the rest of these all-sky camera images, and I'll touch base with you as we discuss the weather station data. September saw the last hurrah of summer with that little peak near the beginning of it. It still stayed nice and warm throughout the rest of September, but fortunately in October we have actually seen a noticeable decrease in temperatures, which is a welcome change. Granted, it's still quite warm for most people's standards. On the humidity side of things, other than a few spikes, things have been pretty stable. Again, one of the big things you want to look for is that minimum humidity, which for the most part has been, well, what you expect out here in the desert, pretty low. Now, I personally have always been fascinated by these heat maps we've been producing, which show the variation of temperature over the course of a day and over the course of the entire month. So we start to see trends versus time and day. Once again, we have the color representing the temperature at that given time on that given day. And if you have trouble with Celsius, once again, there's a nice reference for Fahrenheit down there. Again, we show two different versions of these, one with a color scheme that is stretching from 0 degrees Celsius to 50 degrees Celsius, from freezing temperatures up to 122 degrees Fahrenheit, really what we expect to feel out here. And then we have another version that actually is based on the entire range of temperatures experienced in that given month to show a bit of the variation a little bit better. Finally, our humidity versus temperature scatter plot shows that we have moved out of those monsoon conditions completely. The yellow points on this plot showing the most recent data shows that, yeah, we've actually gotten some points recently where we dropped below 20 degrees Celsius. That's 68 degrees Fahrenheit, which is a welcome thing to have, but it does come with a cost, and that is, it is actually more humid at that time. Of course, when it's that cold out, higher humidity isn't that overbearing. Those high humidity and cool temperature time frames always tend to happen in the morning because as the area around us heats up, humidity will inherently drop because warmer air can contain more water. And so if there isn't a dramatic change in water content in the air, as things heat up, humidity inherently goes down. Now let's go ahead and transition into our solar telescope images. Again, we played through these twice, once with the red view and once with the pseudo color view that enhances that detail. The red view comes from the fact that this is a H-alpha telescope. It filters out everything except a very specific wavelength of 656.3 nanometers. The wavelength of light corresponds directly to the energy transmitted by that light, and the fact that this number is so specific actually comes directly from quantum mechanics. The fact that electrons transition from very specific energy levels to other very specific energy levels within those atoms means that light can be emitted from those atoms at very specific wavelengths. Certain physical conditions can cause some transitions to happen more often than others, and that is why we are looking at this specific wavelength, because the physical conditions in the part of the sun's atmosphere called the coronosphere cause this particular emission of H-alpha light, again, this very specific red. We'll touch base with you again in a few minutes to discuss a specific feature on the sun, and it is one worth taking a closer look at. That dark spot you see moving across the south side of the sun is in fact a sunspot. You might think, well, why are we highlighting something so plain as a sunspot? Well, turns out we are around solar minimum, which means we don't see sunspots so often right now. We will eventually see a lot more of these, but I want to highlight this one because, well, we haven't seen them this nice in quite some time. On the 19th, I took some time out of these normal time lapses to actually get some good detailed images. This close-up shows us a good amount of detail there. Like the image of Mars, this is a stack of the best images of thousands. Sunspots like these occur when the sun's magnetic field gets a bit more complicated. With regions of higher flux than others, it actually causes some areas on the sun to cool down a little bit and thus appear a little bit darker. And that is what we're seeing right in this particular spot here. The appearance of this sunspot could actually be a sign that we're actually starting up our next solar cycle finally. The other thing sunspots give us is a nice frame of reference for the rotation of the sun. We can see it if we look carefully enough otherwise, but it's a lot easier to see when we actually look at the sunspots. So enjoy the motion of our home star, and I will catch up with you as we wrap things up. Thank you for joining us for this edition of Systems Are Go. If you enjoyed it, please let us know. We always like to hear what your thoughts on these things. And if you'd like to be kept up to date on all the happenings at the Library and Observatory, you can sign up for our eNewsletter at the link below. You can also subscribe to this YouTube page to get direct updates on our digital programming here. At this point, I want to give a special thank you to the Rancho Mirage Library and Observatory Foundation. Without that foundation, we would not be able to make videos like these. Also, a special thank you to our docents and to Lauren Zuckerberg, our observatory coordinator. Thank you all for being here, and please remember to just go out and keep on looking up.